Hello, students. Welcome back to my class. And as usual, at first we will begin our Vandana. Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Para Brahma, Tasmai Sri Gurave Namah. Shuklam Brahma Vichar Sar Parama. आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीमवयदां जाढ्यान्धकारापहां हस्ते स्फाटिकमालिका विदधति पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदां न चौर्यहार्यं न च राजहार्यं न भातृभाज्यं न च भारकारी व्यये कृते वर्धत एव नित्यं विद्याधनं सर्वधनं प्रदानं विद्याधनं सर्वधनं प्रदानम्. Okay, students, so what are we practicing? We are practicing some questions which can be asked in SEE examination. So these are the sample questions. So if you practice such more number of questions, definitely you will deserve outstanding marks. So today is Saturday, 13th of Vaisakh 2077, and today I have thought to solve some questions which were asked in the messenger group. So right now we have got two messenger groups, one from Anupam Vidyasadan, which is located at Lazimpat, and another is from Precious National Academy, which is located at Mananget, Mepi, Kathmandu. So students, if you have got any problem, you can just click the photo and send it to my messenger or in my email. Then it will be solved easily. Now I'm going to solve the questions which were submitted by Neeraj Yadav of Anupam Vidyasadan. So in today's class, we are solving some numerical problems. Let me check them. So the questions are already downloaded. I'll write the question first and then we'll discuss. Okay, question number one. Question number one. What does the question say? A man of 100 kg stands on the surface of the earth, which has mass, how much? 6 times 10 to the power 24 kg, and radius 6,400 kilometer. Calculate the gravitational force between them. Okay, students, this is the question. Let's read the question once again. What does the question say? We are discussing numerical problem. So, a man of 100 kg stands on the surface of the earth, which has mass 6 times 10 to the power 24 kg and radius 6,400 kilometer. Calculate the gravitational force between them. So, first what to do? Solution. In this question, what is given? Let's see. A man of mass, or mass is given missing here. Mass 100 kg. Suppose this is M1. mass of the first body, m1. On the surface of the earth, which has mass 6 times 10 to the power 24 kg. This is M2. M1, here is M2, and radius 6400 kilometer. So this is D. What is this? 100 kg is M1, 6 times 10 to the power 24 kg is M2, 6400 kilometer is D. Calculate the gravitational force between them. Gravitational force means what to calculate? F. Okay, do you know the formula? To calculate F, if M1, M2 and D are given, the formula is F equals to G M1 M2 by D square. Okay, so let's write here. Mass of the man M1 is 100 kg. Mass of the earth M2. Mass of the man M1 100 kg. Mass of the earth M2 6.4 times 10 to the power 24 kg. Distance between them, or radius of the earth, you can write D equals to 6400 km. Students, the SI unit of distance is meter, but it's given in kilometer. Simply what to do? 6400 multiplied by 1000 meter. It comes 6.4 times 10 to the power 6 meter. Next thing, gravitational constant. Capital G equals to 6.67 times how much? 10 to the power minus 11 Newton meter square per kg square. And what to calculate? Gravitational force. F equals to what? So it's given G M1 M2 by D square. So one thing you have to keep in mind, the value of capital G is constant, 6.67 times 10 to the power minus 11 Newton meter square per kg square. Okay, in this question, M1 is 100 kg, M2 is 6.4 times 10 to the power 24 kg, D, distance between them is 6400 kilometer, 6400 multiplied by 1000, 6.4 times 10 to the power 6 meter. Gravitational constant is given, gravitational force we have to calculate. Now, what is the formula? F equals to, the formula is G M1 M2 by D square. Okay, G M1 M2 by D square. So this formula was first derived by the greatest scientist Sir Isaac Newton. So the value of G is 6.67 times 10 to the power minus 11. M1 is 100. M2 is 6.4 times 10 to the power 24 divided by, and D square is 6.4 times 10 to the power 6 whole square. It becomes now Newton. Becomes Newton. Now students, what to do? Multiply 6.67, 100 and 6.4 number wise. Okay, what to do? Simply we have to multiply 6.67 multiply by 100 multiply by 6.4. It comes 4268.8. 4268.8 multiplied by, look at here. Here is 10 to the power minus 11. Here is 10 to the power 24 means they have the same base. We can subtract the powers. 24 minus 11 is 13. Now what is here? 6.4 times 10 to the power 6 whole square. First you do the square of 6.4. 6.4 square. 40.96. 40.96 multiplied by, how much does it come here? 10 to the power 6 whole square. Means 6 to the 12. 10 to the power 12. Now students, divide this by this one. So 4268.8 divided by 40.96. It comes 104.21. 104.21 multiplied by, here is 10 to the power 13, here is 10 to the power 12. Then how much does it come? 10 to the power minus 1. Now students, you just calculate the value. 104.21 multiplied by 10 to the power minus 1 means 10.421 Newton. How much does it come? 10.421 Newton. So a man of mass 100 kg stands on the surface of the earth, which has mass this much and radius this much. Calculate the gravitational force between them. Here mass of the man is 100 kg. Mass of the earth is 6.4 times 10 to the power 24 kg. Distance between them is 6400 kilometers. 6400 multiplied by 1000. It becomes 6.4 times 10 to the power 6. Gravitational force is 6.67 times 10 to the power minus 11 Newton meter square per kg square. Find out gravitational force. What is the formula of F? Capital G m1 m2 by d square. Capital G 6.67 multiplied by 10 to the power minus 11. 100 and here 6.4. And what I did, I multiplied 6.67 multiplied by 100 multiplied by 6.4. It came 4268.8. 1, 2, 3 multiplied by 10 to the power 24 minus 11 means 24 minus 11 is 13. Now 6.4 square is 40.96. Then 10 to the power 6 whole square is 10 to the power 12. 6 to the 12. When you divide 426.68.8 divided by 40.96, you will get 104.21 multiplied by 10 to the power 1. No, not minus 1. 13 minus 12 is 1. Then it becomes, I did mistake here. So it should be 1042.1 Newton. So the distance between the gravitational force between them is 1042.1 Newton. 1042.1 Newton. Okay, this is the answer of first question. Now students, what are we going to discuss? Second question. Second question is, let me check here. And finally, I forgot to tell you one thing. At last, you have to write down the answer. What to write down? The gravitational force between them is the gravitational force between them is 1042.1 Newton. Okay, let's check it out. Now we'll be discussing another question. Question number 2. What does question number 2 say? Question number 2 says, question number 2. If an object at a distance of 6.4 times 10 to the power 6 meter from the center of the earth, weighs how much Newton? 10 Newton. 10 Newton. What will be its weight? What will be its weight if it is shifted to the distance of 1.28 times 10 to the power 7 meter from the center of the earth. Meter from the center of the earth. Okay. Are you ready? Second question is, if an object at a distance of 6.4 times 10 to the power 6 meter from the center of the earth weighs 10 Newton, what will be its weight if it is shifted to the distance of 1.28 times 10 to the power 7 meter from the center of the earth? So what is this? 6.4 times 10 to the power 6. D1 was distance, and this is W1. What is it? First weight. And the next one is, this is D2. What to find out here? W2. Okay, D1 is given 6.4 times 10 to the power 6 meter. D2 is given 1.28 times 10 to the power 7 meter. F1 is given 10 Newton. F2 we have to, W1 is given 10 Newton, W2 we have to find out. Okay, solution here, D1, D2, W1, W2. Simply we can write D1, D2, W1, W2. D1 is how much? 6.4 times 10 to the power 6 meter. D2, 1.28 times 10 to the power 7 meter. W1, 10 Newton. W2, we don't know. Now, what is the formula? We have to use the formula. W2 by W1 equals to D1 square by D2 square. What is the formula? W2 by W1 equals to D1 square by D2 square. Students, what do we have to calculate? W2. So W2 equals to D1 square multiplied by W1 by D2 square. Now substitute the value. D1 square means 6.4 times 10 to the power 6 whole square multiply W1 is 10 by D2 is 1.28 times 10 to the power 7 whole square. Okay, friends. Now what to do? We have to calculate 6.4 square. 6.4 whole square equals to 40.96 multiply 10 to the power 6 whole square is 10 to the power 12 multiply 10 by 1.28 whole square. 1.28 whole square is 1.6384 multiplied by 10 to the power 7 whole square is 14. Okay, what to do now? 40.96 divided by 1.6384. Okay, first you divide it. 40.96 divided by 40.96 divided by 1.6384. It comes 25. How much it came? 25 multiplied. Look at here. 10 to the power 12, 1. 13. 13 minus 14 means 10 to the power minus 1. It comes. How 10 to the power minus 1? Here is 10 to the power 12 plus 1. 13. 13 minus 14 is minus 1. So 25 multiplied by 10 to the power minus 1 means 2.5 Newton. How much? Therefore, I will write down the weight at that height is 2.5 Newton. This is the answer. So once again, let's discuss this before heading to third question. Question number second says, if an object at a distance of 6.4 times 10 to the power 6 meter from the center of the earth weighs 10 Newton, what will be its weight if it is shifted to the distance of 1.28 times 10 to the power 7 meter from the center of the earth? Question is here. I have marked 6.4 times 10 to the power 6 meter as D1, 1.28 times 10 to the power 7 meter as D2, 10 Newton as W1, and what will be its weight means W2. Here, D1 6.4 times 10 to the power 6 meter, D2 1.28 times 10 to the power 7 meter, W1 10 Newton, W2 find out. What is the formula? W2 by W1 equals to D1 square by D2 square. We have to calculate W2. So formula is D1 square by D2 whole square multiplied by W1. Substitute the value. D1 is 6.4 times 10 to the power 6 whole square. W1 is 10. D2 is 1.28 times 10 to the power 7 whole square. 6.4 whole square is 40.96. 10 to the power 6 whole square is 10 to the power 12. 6 to the 12. And here 10 to the power 1. 1.28 whole square is 1.6384. And 10 to the power 7 square is 10 to the power 14. Divide 40.96 by 1.6384. It comes 25. Here is 10 to the power 12 and 1, 13. And down is 14 means 13 minus 14. Dividing 10 to the power minus 1, it comes 2.5 Newton. The weight at that height is 2.5 Newton. Okay, we have discussed second question and solved already. Can I write it out? Okay, let's discuss question number 3. These questions were kept in our messengers group, so I am solving it, and you can practice such type of more questions so that you will be in optimum level. You can solve in type of questions. Question number 3. Question number 3 says, the mass and radius of the moon are. Question number 3. The mass and radius of the moon are 7.2 times 10 to the power 22 kg and 1.7 times 10 to the power 3 kilometer respectively. Calculate small g. What is the weight of a man in moon with mass 60 kg? Students, let's check here what is given. Let's write here solution. Before that, let's read once again and mark the given components. Mass and radius of the moon are 7.2 times 10 to the power 22 kg and 1.7 times 10 to the power 3 kilometer. Calculate g, acceleration due to gravity on the moon. What is the weight of a man in moon with mass 60 kg? Students, what is this? Mass of the moon. What is this? Radius of the moon. It is capital M, it is capital R. Then we have to calculate G. And here is given mass of the person is 60 kg. What is the weight? Solution here. Mass of the earth. Mass of the moon. M. 722 kg. Radius of the moon R 1.7 times 10 to the power 3 kilometer. Students, what to do? Shall we keep kilometer or change into meter? Very simple, we have to change into meter. How to change? 1.7 multiplied by 10 to the power 3 multiplied by 1000 meter, or you can do 1.7 times 10 to the power 3, 4, 5, 6, 10 to the power 6 meter. Right? 1.7 times 10 to the power 3 kilometer means 1.7 times 10 to the power 6 meter. Gravitational constant. Capital G. What is the value? That is 6.67 times 10 to the power minus 11 Newton meter square per kg square. Acceleration due to gravity. G equals to what? Weight of the man. W equals to what? Okay, students, what did I write here? Mass of the moon 7.2 times 10 to the power 22 kg. Radius of the moon 1.7 times 10 to the power 3 kilometer. Changes into meter 1.7 times 10 to the power 6. How? By multiplying with 1000. Gravitational constant. Capital G is constant. It is 6.67 times 10 to the power minus 11 Newton meter square per kg square. Acceleration due to gravity. We have to find out. Weight of the man. We have to calculate. Now, first of all, G. What is the formula to calculate small g? Right, that is the Gm by R square. What is the value of G? G 6.67 times 10 to the power minus 11. M, mass of the moon 7.2 times 10 to the power 22. R 1.7 times 10 to the power 6 whole square. As I said earlier, we have to multiply the whole number 6.67 and 7.2. Let's multiply. 6.67 multiplied by 7.2. It comes 48.024. 48.024 multiplied by, student look at here, 10 to the power minus 11, 10 to the power 22 means 22 minus 11, 11, okay. 1.7 whole square, 1.7 whole square, how much does it come? 2.89 multiplied by 10 to the power 6 whole square, 10 to the power 6 to the 12. Now you divide 48.024 divided by 2.89. It came 16.61. 10 to the power 11, 10 to the power 12 means 10 to the power minus 1, 1.66. 1.6766. What is the SI unit? Meter per second square. 1.66 meter per second square. What is this? This is the value of small g on the surface of moon. Again, W. What is the formula of W? Weight equals to m multiplied by g. M is 60 multiplied by 1.66. How much does it come? Let's multiply. 60 multiplied by 1.66. 99.6. Newton. Students, what did I do? I calculated the value of small g and calculated the value of W. Once again, let's see here. In this question, mass of the moon is given, which is 7.2 times 10 to the power 22 kg. Radius of the moon, 1.7 times 10 to the power 3 kilometer. When we change into meter, it becomes 10 to the power 6 meter. 1.7 times 10 to the power 6 meter. Gravitational constant, 6.67 times 10 to the power minus 11 Newton meter square per kg square. It is constant. Acceleration due to gravity, we need to calculate. Weight of the man, we have to calculate. Now, number 1, G equals to Gm by R square. Capital G, value is 6.67 times 10 to the power minus 11. Mass of the moon, 7.2 times 10 to the power 22. And R, radius of the moon, 1.7 times 10 to the power 6 square. We multiplied 6.67 and 7.2, we got 48.024. 10 to the power minus 11, 10 to the power 12, 10 to the power 11, 22 minus 11, 11. 1.7 whole square, 2.89. 10 to the power 6 whole square, 10 to the power 12. When 48.024 is divided by 2.89, the 6 one, 10 to the power 11 minus 10 to the power 12 means it comes 10 to the power minus 1. The value of G comes 1.66 meter per second square. Second part is W equals to mg. 60 times 1.66 means 99.6 Newton. Finally, what to write? After writing this, then you have to do, let me write it out. This side. If you write inside the box, it's quite better. So the examiner will see it clearly. So G equals to 1.66 meter per second square. W equals to 99.6 Newton. Answer. Okay. You know the steps. You must focus on it, how it is done, which formula is applied. Okay, my dear students, let me write out this one. Now we are going to discuss question number 4. So, in the messenger group, I have just got the questions from the chapter 4. If you feel any difficulty in other chapters, you can just post there. I will be solving accordingly. Okay? What does the question say? Question number 4. Question number 4 says, Find the question number 4. Find small g on the top of Mount Everest, Mount Everest, which is 8848 meter above the sea level. The mass of the earth is 6 times 10 to the power 24 kg and radius is 6400 kilometer. Okay, students, what is given here? Find the g on the top of Mount Everest, which is 8848 meter above the sea level. The mass of the earth is 6 times 10 to the power 24 kg and radius is 6400 kilometer. As usual, first we will see here top of Mount Everest, which is 8848 meter, means this is height, altitude, and 6 times 10 to the power 24 kg, capital M, 6400 kilometer, capital I. When you identify, it will be easy. Solution. Now let me start writing from here. Here, height of Mount Everest, h equals to 8848 meter. Mass of the earth, capital M, equals to 6 times 10 to the power 24 kg. Radius of the earth, capital R, equals to 6400 kilometer. I have already solved this one. How to convert into meter? Multiply by 1000. So directly you can write 6.4 times 10 to the power 6. Capital G equals to 6.67 times 10 to the power minus 11 Newton meter square per kg square. Then what to calculate? Acceleration due to gravity at the top of Mount Everest, G prime equals to what? If on the surface, then we are quite only G, but at the top means G prime. So height of Mount Everest 8848 meter, mass of the earth 6 times 10 to the power 24 kg, radius of the earth 6400 kilometer, means 6.4 times 10 to the power 6 meter. Capital G is 6.67 times 10 to the power minus 11 Newton meter square per kg square. It is constant, okay? What to calculate here? Acceleration due to gravity at the top of Mount Everest is to calculate. So that is G prime, okay? So now, what is the formula? One formula is there, do you know? G equals to Gm by I square. But this formula is applicable for the acceleration due to gravity on the surface of heavenly body or earth. But here is given altitude, x. So G equals to Gm by R plus h whole square. Remember this formula. G equals to Gm by R plus h whole square. Now others are very easy. Substitute the value. Value of G is 6.67 times 10 to the power minus 11. Capital M is 6 times 10 to the power 24 by R. What is the value of R? 6.4 times 10 to the power 6 plus h is 8848 whole square. What is done? Capital G is 6.67 times 10 to the power minus 11. Capital M is 6 times 10 to the power 24. R is 6.4 times 10 to the power 6. And H is 8848. Now let me multiply 6.67 multiplied by 6. It comes 40.02. 40 point 10 to the power minus 11, 10 to the power 24 means 24 minus 11 is 13. Very easy idea. Now down what to do? Here we have to add everything. Eh? Now type bracket 6.4 multiply 10 to the power 6. What did I do? Bracket, then 6.4 times 10 to the power 6 plus 8848 bracket close. 8848 bracket close whole square equals to 4.10 multiplied by 10 to the power 13. Okay, so 10 to the power 13, 10 to the power 13 cancel. Simply you divide 40.02 divided by 4.10. 7 was also there, equals to 9.74. Or if we do 9, that only 10. 9.76, you can write 9.76 meter per second square. 9.76 meter per second square. Therefore, acceleration due to gravity at the top of Mount Everest equals to 9.76 meter per second square. As the altitude increases, the value of small g decreases. Why? Because they are inversely proportional to each other. They are inversely proportional to each other. In this question, height of Mount Everest is given, mass of the earth is given, radius of the earth is given. Capital G, if it is not given, then we have to write down. It is constant. 6.67 times 10 to the power minus 11 Newton meter square per kg square. And acceleration due to gravity at the top of Mount Everest we have to calculate. Remember the formula. G prime equals to Gm by R plus H whole square. Substitute the value of G, M, R, H whole square. Multiply and cancel, divide, the answer comes 9.76 times 10 to the power, 9.76 meter per second square. Acceleration due to gravity at the top of Mount Everest is 9.76 meter per second square. Okay, let me have it out. Question number 4. Let me see whether there are more questions or not. So students, you have to try. So after watching this video or during this time also, you just try some more questions, and if there is any doubt, you can post. Now next question is question number 5. If you weigh 588 Newton on the earth, how far you should go from the center of the earth so that your weight will be 300 Newton. What is given here? Radius of the earth is 6400 kilometer. G on the surface is how much? G on the surface equals to 9.8 meter per second square. Okay, students, this is next question. If you weigh 588 Newton on the surface of the earth, how far you should go from the center of the earth so that your weight will be 300 Newton? Just make one figure. Suppose this is earth. So this is the radius R1, and here 588 Newton, in this altitude 300 Newton. So this distance is given 6400 kilometer, and you have to calculate this distance from here to this one. Okay. Solution here. If you weigh 588 Newton, means W1 equals to 588 Newton. Okay. Then this, what is 300 Newton? W2 300 Newton. W1 is 588 Newton. W2 is 300 Newton. Then radius of the earth is absolutely, that is D1 is 6400 kilometer. Means directly what can you write? 6.4 times 10 to the power 6 meter. You have to calculate D2. Question says how far you should go from the center of the earth. But if the question says how far you should go from the surface of the earth, then you have to calculate here x. Formula will be different, but here from the center of the earth means D2 is equals to what? Now, such type of question was done earlier. Would you remember the formula? Formula is W2 by W1 equals to D1 square by D2 square. Okay. What to calculate here? D2. So D2 square equals to, what is the formula? D2 square equals to, comes here, D1 square multiply W1 by W2. So or D2 equals to root under D1 square multiply W1 by W2. Okay, my dear students, now just put the value. What is the value? D1 is 6.4 times 10 to the power 6 whole square multiplied by W1 is how much? 588 by how much does it come? 300, right? Now simply multiply 6.4 whole square. We have multiplied many times. How much does it come? 6.4 square equals to 40.96 multiplied by 588 by 300. Just multiply these two. Oh, here something is missing. 10 to the power 6 whole square is 10 to the power 12. All you can multiply. 40.96 multiplied by 10 to the power 12 multiplied by 588. 40.96 multiplied by 588 multiplied by 10 to the power 12 equals to, it comes 2.408 multiplied by 10 to the power 16 by 300 divided by 300, 8.028 multiplied by 10 to the power 13. How to do? Now square root sign, bracket 8.028 multiplied by 10 to the power 13. How much it came? 8959.91. 8959, oh no, wait a minute, 8959,910.714. We can write simply 8959 kilometer, or no need to write like this, simply you can write. How to change this into kilometer? 8.95 multiplied by 10 to the power 6 meter. 8.95 or 8.96 times 10 to the power 6 meter. That is all. Therefore, the required distance equals to 8.96 times 10 to the power 6 meter. Okay, my dear students, what are we discussing? We are discussing numerical problems based on the chapter 4. In this question, W1 is given, W2 is given, D1 is given. We have to calculate D2. As usual, formula is W2 by W1 equals to D1 by D1 square by D2 square. But we have to calculate D2 square. So D1 square multiply by W1 by W2. Now D2 equals to root under. Substitute the value of D1, W1, W2. Multiply, divide. It comes 8959910.714. So this can be written as 8.96 meter. So the distance must be longer than previous one because the weight has decreased. Okay. So please you try this sum once again so that you will be more confident. Now students, the last question which we are going to discuss is question number 6. Students, are you practicing? So while watching my video, only watching doesn't work. What you have to do? You have to practice side by side. How many times? As I said, if you know it, practice one time. If you don't know, then what to do? Learn it, practice 3 times. That is the spirit. Okay? Question number 6 says, let me write here, to estimate the height of the Kosi bridge over a river, a stone is dropped freely in the river from the bridge. The stone takes 2 seconds to touch the water surface. Calculate the height of the Kosi bridge. Kosi from the water level. Okay. My dear students, first of all, let's read the question once again. What does the question say? To estimate the height of the Kosi Bridge over a river, a stone is dropped freely in the river from the bridge. The stone takes 2 seconds to touch the water surface. Calculate the height of the Kosi Bridge from the water level. So, solution. What is given here? 2 seconds. Time taken, t equals to 2 seconds. We are dropping something. Means what should be there? Acceleration due to gravity. Acceleration due to gravity. We write here g. G equals to 9.8 meter per second square. While dropping, the value of small g will be positive. While throwing something upward, value will be negative. T is given, g is given, height h equals to what? T is given, g is given, h we have to calculate. Is there any formula? We know initial velocity u equals to 0. U equals to how much? 0. Now, formula is it? H equals to, what is the formula? What is the formula of H? Very easy. Ut plus half gt square. H equals to ut plus half gt square. U is 0 multiplied 2 half 9.8 2 square. 0 to the 0 plus 9.8 multiplied by 2 square is 4 by 2, 19.6 meter. Therefore, the height of the Kosi Bridge equals to how much? 9.6 meter. This is the answer. What is this? Answer. Once again, let's see. In this question, 2 seconds time is there, and acceleration due to gravity on the earth is 9.8 meter per second square. We have to calculate the height, initial velocity we have to write here. This is logical one. What is the formula? H equals to ut plus half gt square. We have taken this formula from equation of motion, right? For falling bodies. U is 0 multiplied 2 plus 1 by 2. G is 9.8. T is 2 square. 0 2 is 0 plus 9.8. 2 square is 4 by 2. And we can cancel here 2. 9.8 to how much? 19.6 meter. So the height of the Kosi Bridge is 19.6 meter. Okay, my dear students, what did we do today? I have solved some questions sent through the messenger group, and you have practiced in your own copy, right? It's good. So you need to continue such activities regularly so that you can achieve better marks. And our online classes are also going on. If you have not connected, please install, download, go in Zoom cloud meeting, and in the messenger group I have already kept my ID number and password. You can connect at the time every day from 2 to 4, 2 p.m. to 3 p.m. 1 hour, one group, and 3 p.m. to 4 p.m. another hour, another group. Like first session for precious National Academy students, and second session for Anupam Vidyachalan students. So have a nice and wonderful day. Thank you very much.